So today we are going to do the rate analysis of reinforced cement concrete RCC for the ratio 1:2:4. The concrete ratio is 1:2:4 and we have to do the rate analysis of RCC. So there will be calculation of steel also in this rate analysis, not only concrete, the ingredients of concrete, cement, sand and stone, but also steel, because this is not simple concrete, this is not plain cement concrete, this is reinforced cement concrete. So we have to calculate the quantity of steel also per meter cube. Okay, so first of all let us assume a weight volume of the concrete of 10 meter cube, just like the earlier case, 10 meter cube. So for 10 meter cube of weight volume, the dry volume will be 52% more than the weight volume. So what will be the dry volume? Ten meter cube plus 52% of 10 meter cube. So 10 plus 5.2, ultimately 15.2 meter cube is the total dry volume of the ingredients. Now the ratio is 1:2:4. Now what is the total of these ratios? 1 plus 2 plus 4 is 7. So the total of these ratios is 7. 1 is the contribution of cement, 2 is the contribution of sand and 4 is the contribution of stone ballast in this concrete mixture. So first of all let us calculate the quantity of cement. What was the total dry volume? We found out 15.2. Total ratio, total of the ratios is 7, and this is the ratio 1:2:4. So 4 plus 2 plus 1 is 7. And since we are calculating the quantity of cement, what is the contribution of cement out of this 7? 1. So multiplied by 1. How much shall we get? We get this as 2.17. Let us assume 2.2 meter cube. So 1 meter cube is equal to actually 30 bags of cement. So 2.2 meter cube will be equal to 66 bags of cement. 30 into 2.2, ultimately 66 bags of cement will be required. So now let us calculate the quantity of fine aggregates or sand. Total weight dry volume is 15.2. Total of the ratios is 7 because the ratio was 1:2:4. Contribution of sand is 2. So ultimately we get 4.4 meter cube is the quantity of sand. What is the quantity of stone ballast? 15.2 divided by 7 multiplied by 4 is the contribution of stone. Multiplied by 4. It will be 8.8 meter cube. So in this way we have calculated the quantity of cement, sand and stone. Now it is time to calculate the quantity of steel. Okay. Now the volume of steel is assumed to be, the volume of steel is taken as is taken as 1% of volume of concrete in beams and slabs. In beams and slabs. Suppose we are doing this rate analysis for beams and slabs. Okay. So, what is the total volume that we have taken initially? The weight volume was taken as 10 cubic meter. So 1% of 10 cubic meter .1 cubic meter. This is the volume of steel. This is the volume of steel. Okay. Now, steel is not calculated in terms of cubic meter. Steel is always calculated in terms of its weight, kg, quintal, etc. So we'll have to convert this 0.1 cubic meter of volume of steel into its weight. So we need to find out what is going to be the weight of this 0.1 cubic meter steel. So how to find out? Weight of steel is equal to volume of steel multiplied by unit weight of the steel. Now volume of the steel we have found out to be 0.1 cubic meter, and the unit weight of the steel is 78.5 quintal per meter cube. Now it is 0.1 meter cube is here, multiplied by 78.5 quintal per meter cube. So this meter cube will get cancelled. What will remain? Only the quintal. So the weight of the steel for this particular work is 78.5 quintal. Okay. Now after calculating all these quantities, stone, sand, cement and steel, we have also taken bending wire here. This is bending wire, suppose 1.5 kg. This is a lump sum we have taken. The labors are fixed and some extra labors are required. These labors are required to prepare the concrete, and these labors are required for fitting and placing of the reinforcement, bending, fitting of the reinforcement of the steel. Okay. And these are the labors required for placing the concrete, for providing the formwork, etc. So these are fixed values. So after adding all these values, we get the total. Just like the plain cement concrete case, we get the total, and on the total of labor and material charge, on the total we add 1.5% water charge and 10% contractor's profit. So after adding the labor and material charge and 1.5% water charge and 10% contractor's profit, we get the grand total. And this grand total is calculated for 10 meter cube. So grand total divided by 10, we get the rate for 1 meter cube. That is 11,000. That we, in this case, we have found 11,000 868 rupees per meter cube. Okay, so that is the rate analysis for RCC work in beams and slabs for the ratio of 1:2:4.